And the last step, we built a stitching software which is called Fovex Panomaker for the processing of the images to create spherical panoramas. And this is it. This is the unit that came out. This is the VR Drive metric. It's here. Let's turn it on. So basically it's one setup for one camera, one lens, and it goes around, takes the images in a sphere to create a 200 megapixel image. And it's a calibrated system together with the software, so there's absolutely no stitching errors. The stitching accuracy is, I think, 0.2 pixels. So what you get out of here, there's no more post-processing needed. It goes around very quickly. You can do normal images, RGB images, or HDRs with 3, 5, or 7 brackets. And basically, it works at the push of a button. So, what are the times for capturing the images? We can create an RGB in 36 seconds for capturing the images, or an HDR with 3 brackets in 1 minute 10. The stitching takes, in no HDR, it takes 1 minute 15 seconds, and in HDR3, 2 minutes 7 seconds. So you see it's a fully automated system. You can do batch processing, uses multiple CPUs on the computer, and uses GPU processing, so the graphics card of the computer, to do the stitching of the panoramas. So you see it's a very fast system. Now let me show you a quick example. This morning when we set up, we did a quick shot outside just to show you a little bit how it works. So here we have created an HDR5. So this is the dark one, obviously. Oops. Oh, sorry. Then also rather dark, medium exposure, brighter, and very bright. So 5 exposures, and we put them together into an HDR, and we tone map this. So we tone map this to show the HDR. So the whole process took 2 minutes for the images and 2.5 minutes, or less than 5 minutes, to create this HDR. And you see all the details outside. You see the sky information. You can also look inside, zoom in, and see the details in the dark. It's probably difficult with the projector, but you can get the idea. And because it's 200 megapixels, you have a lot of detail. And the footprint, you see, it's just a tripod, and we blacken out the top. That's it. So that's the quick example. Now, as I said, it's around 4 minutes for a 200 megapixel image. What are these panoramas used for? So we, in 2D, in 2 dimensions, we use it, they are geometrically perfect because of the system calibration. So it's a photogrammetry calibration of the system. We get 200 megapixels, so 10,000 by 20,000 in JPEG, tone mapped, or in HDRs, and it's ideal for 3D because the output is already geometrically perfect. So now let's move, this is the photography part, now let's move to the interesting bit, which is the 3D. So now we moved from 2D to 3D, and I hand over to Jafar. He's going to explain us a little bit what we can do with the images in the Fovex software and what output we get.
Thank you very much. Hello, good afternoon. So my part is related to converting pixels or 2D information in 3D. So in the first step in Fovex software, we need to import images. So as soon as you have individual panoramas, in the software you can under the group of VRDM, which has spherical images. You can click on Add Images. You can choose Image Folder. And if you have already hundreds of images, you can load all these images in the software. Or if you would like, you can press Add Images and select the individual images. So this is just for convenience. Next step. Next step for us is to scale the project. Otherwise, dimensions will not be corrected in a later process. So there are some ways to define a scale for photogrammetry project in this case. You either use a manual way. I start from here. You pick up 2 points in 3D. You go there by a ruler or a meter, measure the distance, and you measure those points in the images. And you define actually this distance as a base or as a calibration for a scale definition. So we usually don't do it because it's time consuming and you may have some error because it's a manual process. There are 2 automated ways to define a scale. One is to use coded target. We have designed a special coded target. We call it photocore coded target. It has this kind of unique pattern. And as soon as you print it with the correct scale, you will end up having 300 micron accuracy for a scale definition. So you can have these kind of layouts placed in your scene, and you use actually these coded targets for a scale definition, but you have to place it in the scene. In case you don't like actually to place these kind of coded targets in your scene, there is also another method. So it depends on you. For automation, you either place this or you go to a second method. The second method works based on vertical movement of the camera. So as you see, there is a bar there, and if you move the camera up, you can measure this distance. So this is exactly the distance between 2 projection centers. We can introduce this distance as a scale definition for the project. And then all your measurement will be dimensionally calibrated. So this is actually the way we propose to scale the projects. Next step is to create a network. Let's say if you have 2 images taken up and down, most likely you have seen it before, or you can imagine it's not difficult actually to create a network for 2 stations, up and down. But as soon as you start moving horizontally, or you start tilting the camera, then it will be more difficult because you cannot use the simplified, let's say, orientation methods to orient the images. Here you see a network generated by approximately 15 stations, and they are actually taken up and down, and the operator also moved in the scene. You can create these kind of networks automatically. So by pressing a button, you can create a network of multiple stations. Why this is important? Because all measurements will be in a unique coordinate system. So if you measure in, for example, one set of images from one side of the scene, you will have the measurements coordinates in the same reference, in the same coordinate system of the other side of the scene. Imagine this place. If you take some pictures here, if you move over there, after all, you can link all of them, and everything will be in a unique coordinate system. So this is very good when you have large projects. Otherwise, probably to a station, let's say a stereo panorama would be sufficient. Then the next step is, of course, this is the key. If you have a scale, if you have oriented network, the next step is to do 3D measurement. This is one of the export possibilities from our software. You create a 3D model, you start drawing on the images, and you build a CAD model. As soon as you have this completely done, we have also an option for you to export it as DXF. If you would like to process it with a third-party software, if you would like to import it in Maya, in AutoCAD, and other softwares. There is also another export possibility in the software, to export it as a project file for color Panotour software, KPD format. There actually a template project will be created which consists of images, hotspot showing the location of the images taken, or let's say camera station on the images, and of course CAD shapes. So when you export this, you will get the template, and you open it in a color panel tool, and there you can customize it, for your virtual tour. This is a snapshot we created as a test project for ourselves. It consisted of 6 panoramas taken from different locations. We need to have internet to show this virtual tour to you. So basically, you have a virtual tour, but it is enriched with dimensional information. Lines will appear on top of the images, and as soon as you move with mouse over them, dimensions will be shown. So before going to this part, maybe it makes sense to show you some of the examples actually we did this morning. We took some pictures in front of this cinema. These are actually the individual images. Let me go to the folder of the images and show you what was the sequence. So we took one up and down, as you see here. If I move it like this, you notice it has a vertical parallax. And then we move to the next station, like this. So we have a horizontal movement and a vertical movement. And what we did, actually, we imported to Fovex Measure 3D software by pressing this button. Natural features, or let's say the key points, were extracted, then they matched together, and they created such a network. If I zoom in here, and of course give a proper scale to show the camera location, you see the 2 balls here are actually the location of the camera. The green actually spot shows the location of tripod. This is just to find out the orientation of the spheres, and this is the second station. And these purple points are actually the key points, which show actually the layout of the scene already. So from here, you can build up, because you have a network, you have the orientation, and actually this is the key to open the 3D measurement. You can start doing 3D measurement. I started doing it almost 1 hour ago, but I was not successful to finish. Let me show you what I did. For example, I measured this. They are here in 3D. I measured a part of the street right here. Now, of course, you can continue building your CAD model. This part is with the manual interaction, so this part is not automated. But of course, as soon as you have the network already here, it helps you a lot, to continue this part. So this is related actually to CAD modeling. I pass to Urs to conclude and provide you a summary.
If I found the PowerPoint, yes. Okay, so to sum up, what we have, there's 2 products. One is the VR drive that you already know. This is the typical photographer product, ideal for panoramas, gigapixels, object movies, etc., etc. It's very universal. You can use your own camera. You have full flexibility, and it's affordable or more affordable than this one. This one is the VR drive metric, and we use it really when you have to do massive tours, maybe of a city. You have to do hundreds of panoramas. You don't want to mess around with the stitching. You do lots of 32-bit HDRs, then this is a good tool, or forensic projects, or for the police, or for the 3D measurement applications. Or if you want to go from a scene really into 3D, then this is the tool. That sums it up. We open now for questions. Oh, I forgot to say one last thing. Of course, this is just... We started to build this product. We presented it first time in Photokina, so it's about 6 months old. We now did, over the winter, we integrated the spherical images into Fovex software. But now we have done this part. Of course, there's the next step, and this will be announced in September. So 4 months from now, we're going to have another module that we're probably going to show next time we see each other at IBRPA. Okay, so any questions? Yes, please.
Is the vertical movement automated, or do you do that by hand?
Right now, it's not automated, but we will build a special tripod where it will be automated. So it will be much simpler. So the scaling will be done like this automatically. Yes. Questions? Yes.
A real basic one. Can you pause the rotation if somebody walks in front? You can
Yes.
pause and start again.
Absolutely. Yes, like with the other VR drive, we have a pause function. You can connect with wireless to it, and you just pause it, you wait for the scene to clear, and you press resume, and it will continue taking the images. And with the grouping, it sorts out the double images automatically, so you don't have to worry about that. Yes, please.
Yes. I'm just curious, when you move the camera horizontally, how do you group everything into the same space? You said it was recognizing that
Yes.
it was the same space?
It's automatically recognizing, it's like when you do stitching, it finds control points. It's the same thing in the 3D software. You go sideways, it will look for matching points and it will kind of stitch it together into the network. And you have to respect certain rules. You cannot move too far. You have to go a couple meters. So the intersection angle to the object is ideal to find those control points. Yes, yes please.
Blue sky with the clouds moving across. Can you add a filter or something to or identify certain areas to avoid that?
It's a good question. So problem is movement, really. We have anti-ghosting in the Panomaker, so to remove those artifacts, but still it's problematic. Also problematic is when you have occlusions. So when you move and something is in the way, of course you cannot measure something which is behind a pillar or behind something. And so movement is a problem also when you deal with laser scanners. It's the same problem when you have movement or when you have glass reflections. That will not give points, of course.
So is there a manual override that you can do for some of those things, like to zone out something or to group a series of points and tell them to...
No. The idea is to avoid the movement, really. Yeah. To have different, especially different viewing points to avoid the movement.
Just to answer you precisely, in case you have blue sky, it means that there is no feature. And if you have a slight misalignment error, you never notice it. So this is one. If you have these organic, let's say a small movement, of course they will appear as residuals and they will be removed, when you do deghosting. So this is related to that part. If you have large errors, we will remove it, but because we have internal threshold, which is actually defined by the accuracy of stitching itself, it goes through different phases, and it filters out actually large errors. And if it sees that these points are bad points, it automatically rejects them. So this is actually the reason that we will end up having a panorama even for such a complex scene. Everybody is moving there. You have very low texture at the ceiling. Floor, of course, is not very much visible. And if you look to a static scenes, you see that they are very well stitched together. But dynamic objects, of course, you see that they are like ghosts, or some of them are just like blended top of the previous image.
Okay, and the second question, if I can be cheeky, you're exporting out the XF. Can you export out something like an OBJ with an MTL file or something else which would allow a material to be applied automatically, the texture to be applied automatically to the geometry?
So at this version, we don't have this possibility, but we are working on this, and yeah, we'll come in the future.
Okay, thank you. Any more questions? Yes, please. Precision, yes.
Yes, precision of image stitching or precision in 3D measurement. Sorry? The 3D measurement. Okay. So in order to have accurate 3D measurement, you have to have a perfect sphere, or you have to have perfect stitched images. If I show you quickly here one of the reports we have for example, for this case, you see that the stitching error is already 0.2 pixel. This is 1 sigma. If you multiply it by 3, it still is around half a pixel. So maximum error you would expect in the image, of course, it could go above actually this value, but statistically, it's around half a pixel. So from the photogrammetry, or let's say from intersection rule, if you just project this half a pixel to the scene, it depends on the scale you have, the distance of the station, and the object, the distance of the object from your camera station. For example, if I would like to measure this room, I will have accuracy less than a centimeter. Yes. Less than a centimeter. So of course, RMS could be even a better value. Usually in 3D applications, you report RMS value, which is a sort of average value, or you report the maximal value. Maximal value, of course, it's a trust for you, because if you claim that it is, for example, a centimeter, it never exceeds a centimeter. But if you say, for example, I have RMS value of 2 millimeter, it could be even multiple of 5 of it. It could be even a centimeter. So for this room, you will have an accuracy of a centimeter.
Any more questions? Yes, please, on the balcony.
For bigger than 200 file on the new module, can you use a logger lens like a normal or telephoto lens?
Well, at this stage, we use a Canon 6G and a 20mm lens because wide angle, because it allows us to capture the scene very efficiently. Of course, if you use a very large lens and go big pixel, it will take much more time. This is not the goal of this tool. The tool is to create spheres quickly to be able to measure in them. So, but we are looking into upgrading the system all the time, get newer cameras, and get even more resolution. That's certainly on the roadmap. Yes. Yes, please.
You're talking about measurements, but are you developing like some kind of user interface for like third party to be able to take measurements based on 2 reference points?
Third party in a viewer?
No, like we create, but somebody else can take the measurements. Is there like some work being done? Say for example, if somebody would want to put something in here and we make a virtual tour from this area, but he needs to find out what is the distance from there to there. How does that happen?
You could combine both. You could use the metric device to create a virtual tour, and the person with the FOX software and calibration could do the measurement in those images, even if it's remote. That's not a problem.
Yeah, but you still need like FOVEX software, etc., etc. It's not like you just go to a browser, open up the virtual tour.
No, it's not as easy as that. So you need, there might be a viewer in the future which is web-based, but at the moment it's a local software that we need to use. Any more questions? Okay, thank you very much.